Today we'll discuss ISI's MTech QROR 2020 PQB Group E1 Mathematics paper. And the first question is, find the area enclosed by x equals -1, y equals 0, and y equals x square plus x plus 1, and the tangent to the curve at 1, 3. Now we'll find equation to this tangent. So dy by dx, it will be 2x plus 1. Now dy by dx at this point P, it will be simply 3. So this equation will be y minus 3 equals 3, x minus 1. So equation of this tangent will be y equals 3x. So now we have this parabola opening upwards whose vertex is at -1 by 2 and -1 by 4. So we'll draw this parabola opening upwards. And then we have this tangent drawn at 1, 3, which passes through origin. So this point is 1, 3. Now we need to find area bounded by x equals -1, y equals 0, that is x-axis, this curve, and tangent to this curve. So we have to find this area. So this area, it will be given by this integral from -1 to 1, area of this parabola, which is x square plus x plus 1 dx, and then minus area of this triangle, which is 1 by 2 and then 3 into 1. Now this integral, it is from -a to +a. This x will be an odd function, and x square and 1, it is an even function. So it will be 2 times 0 to 1 x square plus 1 into dx, and then minus 3 by 2. So this value will be 2, and then x cubed by 3. So it will be 1 by 3, and then plus x, which is 1, minus 3 by 2. So it will be 8 by 3 minus 3 by 2. So it is 16. 16 minus 9, 7. So it will be 7 by 6 square units. So area of this closed figure is 7 by 6 square unit. So that is the answer to this part A. Now we'll come to this part B, which says a conical tent of given capacity has to be constructed. When it says given capacity, that means volume is fixed. So we know that volume of a cone is 1 by 3 pi r square h. So now we have relationship between h and r. We can write h as 3v upon pi r square. Now we need to find ratio of height to radius of the base for the minimum amount of canvas required for the tent. Now we know that amount of canvas required is equal to its curved surface area, which is pi rl. Now the minimum amount of canvas required is when this c is minimum, and when c is minimum, c square is also minimum. We can write c square as pi square r square into l square, and L square is r square plus h square. Now we can write h as 3v upon pi r square. So we'll write c square as pi square r to the power 4 plus r square into h square. So there will be 9v square upon pi square into r square. Now we'll differentiate c with respect to r. So we can write 2c dc upon dr, and it will be pi square 4r cube and plus 9v square upon pi square, and then differentiation of 1 upon r square will be -2 upon r cube, and it should be 0. From here we can write r to the power 6 as 9v square upon 2 pi square. Now this value 9v square upon 2 pi square, right hand side is positive and this is negative. So it is a point of local minima. So curved surface area will be minimum when the value of r to the power 6 is 9v square upon 2 pi square. Now we'll put the value of v here. Now we'll put the value of v, we'll get r to the power 6 as 9 upon 2 pi square, and here v square will be 1 upon 9 pi square r to the power 4 into h square. This 9 will cancel, pi square will also cancel. We can write r upon h whole square, and it will be equal to 1 by 2. That is, value of r upon h should be 1 by root 2. Now we need to find ratio of the height to radius of the base. So h upon r will be simply root 2, and that's the answer to this question. Now question number 2a is, two complex numbers z1 and z2 lie on a circle with center at origin. So we have a circle whose center is at origin and 2 points are z1 and z2. The tangents to the circle at z1 and z2 intersect at z3. So we draw tangents at z1 and z2 and they intersect at this point, which is z3. So this is 90. Suppose this angle is theta, this angle will be pi minus theta. Now this is suppose O, A, B and C. Now first we'll write rotation for these two vectors. We can write z2 upon z1 as OB upon OA into e to the power iota theta. Now OA and OB, they are same, they are radius of the circle. We can write z2 upon z1 as e to the power iota theta. Now we'll write rotation for these two vectors. So we'll rotate BC to form AC. So we'll get z1 minus z3 upon z2 minus z3, and it'll be equal to AC upon BC and then angle between them, e to the power iota pi minus theta. Now length of tangents, it is same. So AC is equal to BC. We can write this as z1 minus z3 upon z2 minus z3, and it will be equal to e to the power iota pi into e to the power minus iota theta. Now e to the power iota pi is nothing but minus 1. So we can write this as z1 minus z3 upon z2 minus z3. E to the power iota pi is minus 1 and then e to the power minus iota theta. So it will be z1 upon z2. So we'll cross multiply. We can write z1 z2 minus z2 z3, and it is minus z1 z2 plus z1 z3. Now we can write this as 2 z1 z2, and it will be z1 plus z2 into z3. So from here we can say value of z3 must be 2 z1 z2 upon z1 plus z2. 2 z1 z2 upon z1 plus z2, and that is the answer to this question. Now question number 2b is, a periodic function with period 2 pi is defined as fx equals x square when x lies between minus pi and plus pi. So in between minus pi and plus pi, it is x square. So this is minus pi and it is plus pi. Now it's a periodic function, so this graph will repeat. So that is the graph of this periodic function between minus 5 pi and plus 5 pi. We need to determine its Fourier coefficient and Fourier series. Now we know that Fourier series is given by fx equals a0 by 2 plus this summation n varies from 1 to infinite an cos nx plus bn sin nx, where a0 is 1 upon pi and this integral from minus pi to pi fx dx. So there will be x square dx. So it will be 1 upon pi and then x cube upon 3. So it will be 2 times pi cube upon 3. So this value will be simply 2 upon 3 pi square. So that is the value of a0. Now we'll find the value of an. Now an is 1 upon pi and then integral from minus pi to plus pi fx, which is x square, into cos nx dx. Now since it is an even function, we can write this as an equals 2 upon pi and then from 0 to pi x square cos nx into dx. Now we'll take this as first function and cos as second function. We can write 2 upon pi and here will be x square and then integral of cos nx is simply sin nx. So it will be sin nx upon n from 0 to pi and then minus integral from 0 to pi 2x into sin nx upon n into dx. Now sin n pi will be 0. So value of this first expression will always be 0. Now we can write an as minus 4 upon pi, and this integral from 0 to pi x sin nx, and we'll take this n with pi, so it will be minus 4 upon n pi into dx. Now again, this is first function and this is second function, so we can write this as minus 4 upon n pi, and here it will be x minus cos nx upon n from 0 to pi, and then minus from 0 to pi 1, and here minus minus will be plus cos nx upon n into dx. Now we'll put the value of x in this one, so it will be minus 4 upon n pi minus pi cos n pi by n. Now when x is 0, this expression is 0, and here it is integral of cos nx, which will be sin nx, and sin n pi it is 0, so the second part will be 0. Now here pi and pi will cancel. From here we can say value of an must be 4 upon n square into cos n pi. Now cos n pi is plus 1 when n is even, and it is minus 1 when n is odd, so it will be 4 upon n square into minus 1 to the power n. So that is the value of an. And the same way we can find bn, and bn will be 1 upon pi, this integral from minus pi to plus pi x square sin nx dx. Now again we'll use by parts, and if we'll solve it, you'll get the value of bn as 0. So now we have all the three coefficients. So value of a naught is 2 by 3 pi square, the value of a1 is 4 upon n square minus 1 to the power n, and value of bn is 0. So we can write Fourier series for this function as a naught by 2, so it will be pi square upon 3 plus this summation n varies from 1 to infinite an, which is 4 upon n square minus 1 to the power n cos nx, and then plus bn, so which is 0. So that is the Fourier series for this given function. Now question number 3a is a total of n badminton players participated in a recently concluded round robin singles tournament where each player played every other player exactly once. Now each match produced either a winner or a loser. Let Wi be number of matches won and Li be number of matches lost by ith player in the tournament. We need to show that summation Wi square is equal to summation Li square. Now in any match between two players, say players Pi and Pj, there can be two outcomes possible. Either Pi wins and Pj loses, or Pi loses and Pj wins. Now if Pi wins, then Wi will be simply 1 and Wj will be 0. And for this player, value of Li will be 0, and here Lj is 1. Now in the same way, if Pi loses and Pj wins, so Wi will be 0, whereas Wj will be 1, and Li will be 1, and Lj will be 0. Now if we look at Wi square plus Wj square. Now Wi square plus Wj square is 1 plus 0, and here also it is 1 plus 0, so it is 1. And if we look at Li square plus Lj square, so Li square plus Lj square, this value will be 0 plus 1 or 1 plus 0, so it will be 1. So no matter who wins, this sum, which is Wi square plus Wj square, is equal to Li square plus Lj square. Now if we consider all the matches between all the players, then we can simply say that Wi square must be equal to Li square. Now part B is let U equals x transpose A into x, where x is transpose of this row matrix, which is x1, x2, x3. So we can write this U as x1, x2, x3 into A, and A is 1, 3, minus 2, minus 3, 2, 0, 2, 0, 3 into X, and X is this X1, X2 and X3. Now we need to multiply it. So we'll multiply it, we'll get U as X1 minus 3X2 plus 2X3. Next one will be 3X1 plus 2X2, and the last one will be minus 2X1 plus 3X2 into X1, X2 and X3. Now we'll multiply both of them. So then this U will be X1 square minus 3 X1, X2 plus 2 X1, X3 plus 3 X1, X2 plus 2 X2 square, and then minus 2 X1, X3 plus 3 X3 square. Now 3 X1, X2 will cancel and 2 X1, X3 will cancel. So we'll get this U as X1 square plus 2x2 square plus 3 x3 square. Now we need to minimize U using the constraints, which are x1 plus x2 is equal to 2 and x2 plus x3 is equal to 3. So we'll change the entire equation in one variable, and that is x2. So we can write this U as, now what is x1? X1 is 2 minus x2 square. It'll be 2x2 square plus 3. Now x3 will be 3 minus x3 square. So it'll be 4 plus x2 square minus 4x2 plus 2x2 square plus 3, and it'll be 9 plus x3 square minus 6x3. So this U will be 6x2 square minus 22x2 plus 31. Now we need to minimize it. So we'll differentiate with respect to x2. So du upon dx2 will be 12x2 minus 22, and it should be 0. So value of x2 should be 22 by 12 and it will be 11 by 6. Now once we have the value of x2, we can find the value of x1 and x3. Now 3C is, we are given 4 points, 0, 0, B which is 1, 0, C is 3, 0, and D is 5, 0. Now we need to find locus of point P such that angle APB is equal to angle CPD. So we'll find slope of all these 4 lines. So let this point P be alpha, beta. So this slope will be beta upon alpha. It will be beta upon alpha minus 1. This is beta upon alpha minus 3, and it will be beta upon alpha minus 5. Now tan theta is m2 minus m1 upon 1 plus m1 m2. So we can write this as beta upon alpha minus 1 minus beta upon alpha upon 1 plus beta square upon alpha minus 1, and it should be equal to tan theta for these 2 lines, and there will be beta upon alpha minus 5 minus beta upon alpha minus 3 upon 1 plus beta square upon alpha minus 5 into alpha minus 3. So we can write this as alpha beta minus alpha beta plus beta upon alpha square plus beta square minus alpha, and here will be beta and then alpha minus 3 minus alpha plus 5 alpha square plus beta square minus 8 alpha plus 15. Now here alpha beta will cancel, here also alpha will cancel. Now here one solution that we will get is when the value of beta is 0, and the other solution will be when 1 upon mod alpha square plus beta square minus alpha is equal to 2 upon mod alpha square plus beta square minus 8 alpha plus 15. So we can write this as alpha square plus beta square minus 8 alpha plus 15, and L be equal to plus minus 2 alpha square plus beta square minus alpha. Now in the end we'll replace alpha with x and beta with y. So one of the locus that we'll get is when y is 0, and the other one is this equation of circle. We'll take plus sign, we'll get one equation, and if we'll take minus sign, we'll get other equation, and this is the locus of this point P. Now these are two circles. Radius of this smaller circle is r, and radius of this circle is, say, capital R. And let the center be at origin. Now we can write this point of intersection in terms of parameter theta. We can write this point, say, D as r cos theta and r sin theta. Then P will be minus r cos theta and r sin theta. And the same way, value of A will be minus r cos theta and minus r sin theta. Now we need to find the value of B and C. Now equation of this larger circle will be x square plus y square will be capital R square. Now here value of y will be r sin theta. So we can write x square equals r square minus r square sin square theta. So value of x will be plus or minus under root of r square minus r square sin square theta. Suppose this value is k. So it will be minus k comma r sin theta, and value of c will be plus k and r sin theta. Now we need to find the value of PA square plus PB square plus PC square. Now what is PA square? PA square will be 2r sin theta whole square plus PB square. Now what is PB square? Now here r sin theta will cancel. So PB square will be k minus r cos theta whole square. Now what is PC square? PC square will be k plus r cos theta whole square. So this PA square plus PB square plus PC square will be, now this is 4r square sin square theta plus 2 times k square plus r square cos square theta. Now k square is capital R square minus r square sin square theta. So we can write this is 4r square sin square theta 2. Now k square will be capital R square minus r square sin square theta plus r square cos square theta. So it will be 2r square and then plus 2r square cos square theta. Now here it is 4r square sin square theta minus 2r square sin square theta. So it will be 2r square sin square theta. Now cos square theta plus sin square theta will be 1. So it will be 2 times r square plus r square, and that is what we need to prove. Now question number 4b is a sequence of number an is defined as a1 equals 1 by 2 and an equals 2n minus 3 upon 2n into an minus 1. We need to prove that the summation ak is less than 1 for all n greater than equal to 1. So we can write this an as 2n minus 3 upon 2n. Now an minus 1 will be 2n minus 5 upon 2n minus 1. Next one will be 2n minus 7 and 2n minus 2, and will continue up to a1, which is 1 by 2. Now what we'll do is we'll multiply numerator and denominator with 2n, 2n minus 1, 2n minus 2 and 2. So we'll get 2n minus 3, 2n minus 5 and then 3, 1. And here will be 2 into 2 into 2 n times. So there will be 2 to the power n. Now n minus 1, n minus 2 up to 1, and there will be factorial n. Now what we'll also do is we'll multiply 2n minus 1 and we'll divide 2n minus 1. And with that we'll also multiply and divide 2, 4 up to 2n. So again we'll multiply 2n, 2n minus 2 and then 4 and 2. So we can write this an as factorial 2n minus 1. Now this is 2 to the power n into factorial n, and this also will be 2 to the power n into factorial n. So we can write an as 2n cn upon 2n minus 1 4 to the power n. Now this summation ak, where k varies from 1 to n, will be less than this summation k greater than equal to 1 into ak. Now this is summation k greater than equal to 1 and then 2k ck upon 2k minus 1 into 4 to the power k. Now let 1 upon 4 as sum x. So we can write this as this summation k is greater than equal to 1 2k ck upon 2k minus 1 and will be x to the power k. Now we can further simplify this as this summation k is greater than equal to 1. Now we can write this as factorial 2k upon factorial k square, and we can cancel 2k minus 1. So we'll write this as 2 into factorial 2k minus 2 upon factorial k minus 1 square into x to the power k upon k. Now we can write this summation as this integral from 0 to x, and then this summation, suppose some variable says z is greater than equal to 0 factorial 2z upon factorial z square into some variable say t to the power z into dt, which is 2 into, and this integral from 0 to x 1 minus 4t to the power minus 1 by 2 into dt. Now this integral will be 2 and then 1 minus 4t, and it will be 1 by 2 upon 1 by 2, and this is minus 4 from 0 to x. So here 2 and 4 will cancel, so it will be 1 minus 4x to the power 1 by 2. Now here the value of x is 1 by 4. So this expression will be 0. Value of this summation will be 1. So from here we can say this summation k varies from 1 to n ak, it is less than 1 for all n greater than or equal to 1. And that is the answer to this question.